Hi, this is Pat Johnson, and in this mini lecture, we're going to talk about experiments. Now, we've already talked about descriptive research, we've talked about correlational research, and we're moving on to our third type of research, experiments. And this type of research is really important because this is a time when researchers can use that word cause. So, what is an experiment? Here's a fancy definition. In an experiment, the researcher varies one factor to see if it has an effect on some behavior or mental process under carefully controlled conditions. All that means is when we run an experiment, we have two variables usually, and we change one of those variables to see if it has an effect on the other variable. And we do this all under carefully controlled conditions. And if we do that, we can say cause and effect. We can use that word causation, or A causes B. Okay, so let's start out with our hypothesis. Imagine that I have students who are doing poorly in class, and I also notice that the building is really hot. And let's say I've noticed this over numerous summer semesters, which was actually the case in my classroom. Before our campus was built, we were in the high school, the local high school, in the evening, and the building was really hot. So semester after semester, I noticed that as temperatures went up, grades went down. Now, is that enough information to be able to say that high temperature caused lower grades? Well, no, it's not, because there could be all sorts of other reasons why students are doing poorly in the summer when the temps are harder. Maybe they're off at the beach and just not in class. Maybe they're making up a class that they flunked during the previous semester. There's all sorts of reasons why students might do poor in the summer when the temperature's hot. So we need to run an experiment and see if in fact it's actually the temperature in the classroom that's causing the lower grades. Now, I've been talking about two variables in an experiment, and we have fancy terms for those. They're called the independent variable and the dependent variable. So don't let these two terms confuse you. They're actually fairly easy to understand. And the independent variable is what we manipulate, and the dependent variable is what we measure. In other words, the independent variable is what is thought to be the cause, and the dependent variable is what is thought to be the effect. So let's go back to our example. If we're saying that high temperature causes lower grades, and let me get my camera out of here and just go to the screen. What would we be manipulating? What would we think would be the cause in this experiment? Well, that would be temperature. In other words, we're saying that it's the heat in the classroom that is causing the lower grades. The lower grades would be the effect. So we're saying that lower grades is the dependent variable, while temperature is the independent variable. Let's go to another example. From your textbook, it says we could have a hypothesis that breast milk fed babies will be smarter. And in this one, whether or not the babies get breast milk would be the independent variable. We'd give some babies breast milk and some babies not get breast milk. They might get formula. And then we're going to measure how smart they are. So being smarter would be our dependent variable. Let's go to a drug study. Let's suppose that we have developed a drug that we hope will decrease depression, and we're going to run an experiment on that. Some people are going to get the drug and some are not, and then we're going to measure depression. So depression would be our dependent variable, and our independent variable would be whether or not they get the drug. So, again, when we're talking about independent variable, we're talking about something we're going to have different levels of. It's not enough just to heat up some students and see if they flunk. We need students who aren't heated up as a comparison. It's not enough to give babies breast milk and test and see if they will be smarter. That would just be a correlation. We need to compare the breast milk fed babies to babies who don't get breast milk. If we're testing a drug, it's not enough to just give out our drug and see if it causes a decrease in depression. We have to compare, in other words, we have to manipulate some people getting the drug and some people not getting the drug. So what I'm alluding to is that there need to be different groups in an experiment, where some get the actual treatment, in this case temperature, in this case breast milk, in this case the drug, and some do not. So let's skip ahead for just a second. And the two or more groups in an experiment are the experimental group and the control group. So the experimental group is the group that gets the treatment, and the control group is the group that does not get the treatment. So for example, if we're talking about people getting heated up or high temperature causing lower grades, the experimental group would be the group that gets heated up, and the control group would be a group that would not be heated up. They would be used for comparison. Now, you may be asking, well, what do we mean by heated up? And what do we mean by does worse than? Let's go back to a concept we talked about earlier, and this is the concept of operational definitions. And remember, an operational definition means that we put our terms in such a way that they can be measured. So what could be an operational definition for high temperature for a classroom? Well, we couldn't say something like 150 degrees or 200 degrees because that would just kill them. But what would be a high temperature for a classroom? And maybe you're saying, well, if the classroom was 80 degrees, or maybe if the classroom was 85 degrees, or maybe if the classroom was 95 degrees, that would be hot. And all of those would be hot classrooms. So, which one do you want to go with? Let's go with the one in the middle. And you could go with that one, you could go with that one, you could go with something a little bit higher. But let's say we're going to call our hot classroom the 85-degree classroom. And how much lower? Now you could say, well, if they flunk or if they get less than a C. Well, no, that's not a good definition, because it might be that it's a really hard class with really hard tests and everybody flunks or everybody gets lower than a C. So let's say if there is a 10% difference, if our heated up students get 10% lower grades, we're going to call that good enough to prove that it was the high temperature. So again, in our two groups, our experimental group would get the 85 degrees Fahrenheit. And what would be an operational definition for our control group? This would be a group that would not be heated up. They would just be in a normal temperature classroom. And, let's say we'll go with 72 degrees. 72 would be a nice, comfortable classroom. So our experimental group's going to get 85 degrees, and our control group's going to get 72 degrees. Now, we have to have some subjects. We need people to do this to, and we can't just put students we like in the comfortable classroom and students we don't like in the hot classroom. We got to use a procedure called random assignment. And what random assignment means, random assignment means is that all subjects have an equal chance of being in either group. So, in other words, every subject who's in our experiment has to have an equal chance of being in the control group or the experimental group. Now, how could we do that? Well, we could flip a coin. That was often done in earlier days for random assignment. We could have students count off, which that's not the greatest because I remember as a kid, if we counted off for a sports game, we would put the kid we didn't like between us and our friends. So often it's done by random assignment in a computer generation type system, but any technique that you can come up with where every subject has to have an equal chance of being in the experimental group, the one that gets 85 degrees, and the control group, the one that gets 72 degrees. So let's say we have 40 subjects, and we're going to put 20 here, and we're going to put 20 here, and we're going to do that by going down our roster, and the first student's here, the second student's here, the first student's experimental group, first, second, third, fourth, fifth, sixth, all the way down to assigning number 40 to the control group. In that case, every student had an equal chance of being in either group, and that's random assignment. It's a really important part of an experiment, and please don't confuse random assignment in an experiment with random sampling that we used when we're talking about surveys. Now, in this case, again, we're talking about running our experiment. So we're going to have 40 subjects. We're going to abbreviate that the normal way, big S, little s. There are going to be 20 subjects here, and they're going to get 85 degrees. And there are going to be 20 subjects here, and they're going to get 72 degrees. And then we're going to run our experiment. So we would probably teach them something, test them, and it has to be the same teacher at the same time in the same type of classroom. So in this case, we might use a video lesson that both sets of students, the experimental group and the control group, are seeing at the same time. So everything has to be the same for all these 40 subjects, except whether or not they have that 85 degrees or the 72 degrees. That's what we meant in our definition by under carefully controlled conditions. In other words, we have accounted, everything else is the same except that level of the independent variable. Now, afterwards, after we've run our experiment and we tested them, we're going to compare the results. And if you take a statistics class, there will be statistical formulas that you will learn to compare the results in experiments. This isn't a statistics class, so we'll just say if the experimental group does significantly, and by significantly we said 10% worse than the control group, we can say that heat causes lower grades. And again, why can we use the word cause? We can use the word cause because we have controlled for everything else and only manipulated that level of the independent variable. That's the only thing different between our experimental group and our control group. Okay, so that's how an experiment is done. Now, let's throw in another factor. Let's suppose we're testing a drug, and I just came up, since my name's Pat, and we're going to call it after me. We're going to call it Pat's Miracle Memory Pill. We'll abbreviate it PMMP. We're going to say that Pat's Miracle Memory Pill increases memory. So let's say this time in a drug study we'll use lots of subjects. We have 100 subjects. And this group, so there's going to be 500 here, they're going to get the Pat's Miracle Memory Pill. And these 500 who are randomly assigned to the control group, they get nothing. Now, why is that not good experimental design? Well, if a subject gets nothing, they know they obviously didn't get the treatment. So we need to give them something to make them think that they might have gotten the actual treatment, and that's called a placebo. So this is our control group, and our control group is going to get a placebo. And a placebo is a nothing treatment. In a drug study, it's often a sugar pill, but it's a nothing treatment that makes the experimental group, oops, this should read, did you see that mistake? This should read the control group, that makes the control group think they could be getting the real treatment. So we call that blind. Blind research means that the subjects don't know which group they're in. They don't know if they've received the real drug or if they've received the placebo. Now, that's good, but let's suppose you're the person giving out the drug. You may give off subtle cues to the people who are getting the drug or the people who are getting the placebo. So in other words, that's not good either. That's still biased. In drug studies, we often use what is called double blind. And double blind means that neither the researcher nor the subjects knows who's in which group, so there won't be any bias. And I actually had a student years ago who worked for a drug company that was running research trials on drugs, and her job was just to give out drugs to the research subjects, and the drugs were labeled so that the placebo and the drugs looked exactly alike. And she didn't know, and the subjects didn't know whether they were getting the real drug or whether they were getting the placebo. And obviously somebody needs to know, but it can't be the person handing out the drugs. Again, handing out the drugs or measuring the results. So let's go through our little research here. We're talking about Pat's Miracle Memory Pill, our PMMP, and we're going to have, we'll have 1,000 subjects. And the experimental group is going to get, there's going to be 500 here. And they're going to get the actual drug. And then we're going to have the control group. And these people have been put into the two groups by random assignment. And these 500 are going to get the placebo. And if we do it that way, then, and make it double blind so that neither group knows which group they're in, and neither does the person who is handing out the drug, then we can come up with our conclusion and say that if the experimental group does, in this case, better than the control group, we can say that our drug, PMMP, caused increased memory. Okay, so just to summarize, let's talk about what we've learned about in running an experiment. We've learned that experiments show causation. And we do this by, we're able to say the word cause and effect or causation because we have had random assignment and we have carefully controlled for every other variable other than that level of the independent variable. In other words, everything's the same for the two groups except the level of the independent variable. And if we have done that, then we can truly use the word cause or causation. And that's the highest form of research when we have carefully controlled for everything except the level of our independent variable. Then we can say A caused B.